Okay, so we got to solve for P. It's the only unknown we've got. Okay, well, with a little experience, you see that, well, I could write this as 100 multiplied by 17 to the P divided by 33 to the P. Just rearrange it this way so the things that are to power P are together, right? Now, there are other things I could have done. I could have divided both sides by 100 because it's the one thing over here that doesn't have a P on it, right? Now, I still have people that are going to want to subtract 100 to get rid of that 100. Does everybody understand why that's a really bad idea? You don't get rid of a multiplication by subtraction, okay? But you do get rid of it by division. And you should understand, in terms of the laws of exponents, why that works, okay? But we have this. Now, I could now divide by 100. Something else I'd probably do first, but I can divide by 100, right? So I get 140 over 100 is equal to 17 to the P divided by 33 to the P. So 17 to the P divided by 33 to the P should equal 1.4. Okay? Now what would I do next? And I said something about using logarithms. It turns out in this case we don't have to use logarithms. Exponential model we do. We could have used logarithms, but we don't need to.
Do the p's like?
I'm sorry?
Do the p's like reduce?
Do the p's reduce?
Yeah, because you have a p on top and a p on the bottom, and if they just disappear.
Nah. Think about like 2 to the third divided by 3 to the third. Okay? That's 8 divided by 27, not 2 divided by 3, okay? So you can do simple examples. It's a thought, but no law of exponents allows you to, and this comes back to the point where everybody's allowed you to cancel rather than thinking about what's going on. But you can't just get rid of the p's. They don't cancel. There's no law that allows you.
If you multiplied everything by 33p, that'd get rid of the denominator.
Yeah, but then you'd end up with p on both sides.
Yeah.
You really don't want that. It'd be a natural thing to try, but as soon as you see it, you say, well, what am I going to do now? Well, I better put that on the other side. Oh, now I'm back where I started from. Okay? So it would probably lead you to try something different. Well, there are two things I can do here. And I'm going to do the first one. First of all, 17 and 33 are both to the p power, as you recognized, right? So I can write this like so. And now how can I solve?
Would you just divide 17 by 33?
I could, but I'm not going to yet.
Okay.
Because if I do it, I get a big old long decimal or something.
That would give you just
And
a
it's
single
no longer
exponent.
exact.
That would give you a single exponent though, correct?
It would give you what?
It would give you a single p, something raised to the p power, right?
Yeah, well, we've only got one p now.
That's what I'm saying.
Yeah, it doesn't matter whether we
Yeah.
divide that out and represent it as a decimal, which everybody seems to want to do, because decimals are easier to look at. And I agree, you can tell how big a decimal is. You can't tell how big a fraction is, especially.
Would you multiply both sides by 33 then?
Well, but that wouldn't help because this 33 is raised to the p.
Okay.
So you can't multiply by 33. This side doesn't have denominator 33. The denominator is 33 to the p. Okay? And you got to be, you really have to think through these things. It's real easy to make mistakes. Okay? So, well, if it was 17 over 33 squared, what would we do? you take the square root of both sides, of course you'd have a plus or minus involved, right? Okay? And then you would, even if you did get a plus or minus, when you come back to the model, k's got to be positive. Okay? You're not going to get a negative length, and you're not going to have a negative length, you're not going to have a negative count, right? So you're not going to get negatives. All these numbers are going to be positives, k has to be positive. So even if it was a second power, you wouldn't, you write down the negative, then you say, well, but it can't be, so we'll just use the positive. Okay? Well, that's just a side comment. Hey, what if it was cubed? Cube root. Take the cube root. What if it was 58? Well, you'd take plus or minus the 58th root, and then you dismiss the minus. Well, you want to take roots. I don't want you to take roots. I want you to do exponents. What would you raise this to in order to get rid of that p? I'm sorry?
She said 1 over.
Rest is 1 over
Yeah.
p down.
Yeah, that's what I was hoping you'd said. Okay? And that's what you said. So you should have said it louder. Have some confidence. You're a good student. You can figure these things out, even if you're wrong. I won't make fun of you too much. Okay? So we get this. Right? So 17 over 33 raised to the p times 1 over p equals 1.4 to the 1 over p. So it's 17 over 33 equals 1.4 to the 1 over p. Man, you know what? That didn't help a bit. We still got p. We didn't get rid of p, did we? We just got rid of it in one side. So the first time I lied to you, I didn't. The second time I did. If you remember everything I've said, which is unlikely because I've said a lot of things. Okay? So what are we going to do? This is an important thing. This is an important idea. We've got to be able to do this, but it didn't help. But we did illustrate a lot of laws of exponents, didn't we? So we're kind of at the end of our rope. We've demonstrated the laws of exponents. They don't help. What are we going to do? Well, back to what I said originally, maybe we'd better use logs. Okay? So, dang. Here's an exponent. We inverse exponentiation using logs. Well, we come back to this step. (17/33 to the p equals 1.4, right? Now, how do we express that as a logarithmic equation?
Would it be 17 over 33 log? Hold on, I'm trying to do the math.
Okay, now, one thing you have to be able to do at this point, and you're trying to do it in your head, it's a little bit of a stretch right now. It's pretty good. You see what to do. But you probably ought to write down the rule for equivalence between a logarithmic and an exponential expression, right?
Yeah. Let's be
So
raised to
I don't
8%.
remember what variables I used before, but I'm going to do this. B to the x equals y is equivalent to what? Log to what base?
B.
B is the base of your exponential. It's going to be the base of your log. And you're going to switch y and x. It's going to be log base b of y equals x. Because how do you get the log? To a given base, you have your exponential function to that base. You got your table, you switch columns of your table, you get the log graph, right? And you've switched x and y. Okay? So you see how the function now, here the function was an exponential function applied to x. Here now it's a log function applied to y, but the base is the same both times. So that's worth understanding. It's worth thinking about, okay? This whole example is well worth thinking about. Okay, well, now if you have this, okay, everybody rewrite the equation now.